Hello students, this is Mr. McAllen again, and we're working with polynomials, and in this example we're going to talk about what happens if we have repeated roots. So, um, this is probably not such a great way to start off, but let's just say that you're given a function, and you work very diligently, and you somehow factor this function, and you work and work and work, and you finally get the function to be factored, and you come up with its factors, and you're trying to find its zeros so that you can plot. The reason why I show this first function is because in its standard form, you can tell a lot about it. You can say that, well, it's a third degree function. It should have at max 3 zeros. That's what the polynomial theory says. It should have at max um, two extreme values, as we discussed in the other videos. Let me just write that better: extreme, and it should behave on its ends like x cubed. So it should have x cubed end behavior. So the point of teaching algebra or algebraic methods is so that we can, through the use of algebra, we can turn the function into this um, I guess, factored form of f of x. So now that we have it factored, we can set it equal to 0, and we can set, we have x minus 1, and we have x plus 2 squared set to 0. Now we can understand what the zeros are. So this is the problem, though. So we get x minus 1 equals 0, we get x plus 2 equals 0, and this is really a double root, because if we were to solve this twice, we would get the same answer twice. So I hope you can see that through this video. We get the same linear term set to 0 twice, and what happens is you get what's called a double root. So what does that mean? So here we had x equals -2, and x equals -2 again. So first of all, the way we describe this is we say at x equals -2, the root has multiplicity, and that's a new word maybe, multiplicity 2. Now, I heard some students in class talking about multiplicity, and they seem to know from last year in Algebra 2 what this is. So, I'm going to just describe what it is, but I understand that some of you may already know. But this root here, x equals 1, has this one root. There's no multiplicity at that root. So let's describe how the graph appears, because it should look like on its ends, it should look like x cubed. It should look like it comes in from the left, from the bottom, and goes out to the out and upward as you go to the right. So if I plot the roots at 1 and at -2, because I have a double root here, and I'm just going to put here, I'm going to put here B for bounce, and I'm going to put a T here for through. When you have odd multiplicity, like multiplicity 1 or multiplicity 3 or multiplicity 5, or 7 or 9, odd multiplicity of roots, you basically have a root that's passing through the x-axis. But when you have even multiplicity, you have bounce roots, and that's where the function bounces off the x-axis. So it's important that when you solve and factor and you have varying multiplicities, you take note of that when you go to plot it. And here you can see, as I come into this root, I'm going to bounce, and then I'm going to go through my through root. And to verify this, to make sure we actually have that, we can check that with our y-intercept. And that's why a lot of times when we plot polynomials, we'll say, hey, find the y-intercept. We'll say, let's plug in 0 for x, so f of 0 will equal, in this case, -2 if you plug 0 in. And if you look at the original polynomial we had, if I scroll back, actually it should be, it should be -4. So let me just double check that I just did here. So if I put in, I have 0 minus 1. This might have been just a hasty error on my part. Plus 2 squared. Oh yeah, that would be -1 for the first term, and it'd be 4 for the second term, which would make -4. So again, make sure that you're careful. Don't make the mistake I made. But you could always look back at your original equation in standard form and see what the y-intercept would be, or you could plug 0 in, and as a result, you see I have a y-intercept of 0, -4. That's pretty sloppy. Let me change that. 0, -4. And, so hopefully this lesson has helped you understand what varying multiplicities will do. And just to kind of, if you want to watch this last part of the video, I know I'm probably over my time that I want to spend on this, but if we take these terms and we put them into Desmos, I love using this tool because it's so easy to illustrate what happens. So here we had this polynomial where we had x minus 1 times x plus 2 quantity squared. So right here you can see the bouncing. Now, if I make that a triple root, you'll see it go through again. And there you see I turned into a through root, but overall I changed the polynomial to degree 4, so its end behavior is switched to look like an even function. So, but I can switch that real quick. Let me make this a fourth root, and there I've got multiplicity 4 at -2, and you can see it's bouncing again because you have even multiplicity. And if I change that 1, let me change that to even multiplicity. I'll put a 2 there, and you can see how now the function is behaving like a 6th-degree polynomial, where it looks like an even function as it comes in and leaves, like a w, some people might say. But at the roots, it's bouncing off the x-axis. So you get the idea. You can obviously play with Desmos as much as you like to see the different things and what could happen. And I hope this video helps as far as instruction, so you can visually see what's going on with this polynomial theory. Anyway, have a good day, and I look forward to hearing your comments.